अंदर 2 नंबर. हेलो.
Good afternoon. Welcome to the afternoon session where we will have the panel discussions. And for the first panel discussion, the topic is The first panel discussion, the topic is emerging trends in observation and data simulation. The moderator for this panel discussion is Dr. Indira Rani from NCMRWF, and the rapporteur is Dr. Upal Saha. May I please call upon the rapporteur and the moderator?
Thank you, Anu. So, welcome to the afternoon session of this celebration. So, I will invite the panelists first, Dr. Vijay Talapragada. Dr. S.P. Agarwal. Dr. Randeep Singh. Dr. Sudhir Joseph. Dr. Anand Kumar Das. And Dr. Ashish Rautre. The topic of this panel discussion is emerging trends in observations and data assimilation. So before starting the panel discussion, I will introduce our panelist. Dr. Vijay Talapragada is the senior scientist at NOVA's Environmental Modeling Center, leading and advancing the development of community-based complex coupled earth system models and data assimilation for weather and climate prediction systems. And he serves on various national and international advisory committees for operational NWP, research programs and observational field campaign. Welcome, sir, to this panel discussion. And we have Dr. S.P. Agrawal. He is the director of Northeastern Space Applications Center, Department of Space. And he has taken several initiatives towards effective utilization of space and geospatial technology in natural resource management, infrastructure planning, disaster risk management, weather forecasting, satellite communication application, and geo-governance related applications. Welcome, sir. And we have Dr. Randeep Singh. He is a senior scientist from Space Applications Center, ISRO. His expertise spans satellite remote sensing, geophysical parameter retrieval, radiative transfer modeling, satellite data assimilation, numerical weather prediction, and GNSS meteorology. He is also the recipient of various fellowships and awards. Welcome, Randeep, to this panel discussion. And we have Dr. Sudhir Joseph. He is a senior scientist from our sister organization INCOIS, and he is heading the applied research and research to operation division at INCOIS, and his research interest includes ocean general circulation, ocean modeling, and ocean influence on climate. Welcome, sir. And we have Anand Kumar Das. Dr. Anand Kumar Das is a senior scientist from India Meteorological Department, and presently he is the acting head of Cyclone Warning Division of RSMC New Delhi. And his research interests include mesoscale modeling, extreme weather events, strategic development of decision support system for real-time impact-based forecasting of heavy rainfall. Welcome, Dr. Anand Kumar Das. And we have our own NCMRWF colleagues, Dr. Ashish Rautre. He is a senior scientist from our center, and his research interests include mesoscale modeling, radar data assimilation, land and atmospheric data assimilation, monsoon studies, study of extreme weather events, and regional climate modeling. So we have prepared some questions for our esteemed panelists. So I will ask the first question to our IMD representative, Dr. Anand Kumar Das. So as you know, we have millions of satellite observations. But there are some conventional observation that we call as the anchoring observation, like radio sonde and all those things. So what are the IMD's plan for expanding and improving the observation network and its maintenance so that high quality observations are available for NWP and other applications?
Yeah, IMD already have exhaustive plan, and time to time we have upgraded our observing networks when as per the requirement of science, means understanding of different scientific events, whether any weather extremes, whether weather and climate extremes, or if it is a requirement for NWP systems. So based on that, we upgraded our observing system. So we have also presently have our plan for upgrading the observing network, as it is whether it is a surface based network, that is manual or automated weather station ARG. So we are increasing the number, as we have seen that in the morning, that network coverage of the our observing systems, it is very much representative of whole India, and now we are trying to improve that based on our requirement, specific requirement, like city forecast, urban forecast system. So for that we need far more observations over those areas. So we are now strengthening that observing network. So not only the surface network, that we are also now expanding our observing system upper air. So that RSRW now, all our RSRW now upgraded to GPS based system. So now that numbers from 42 it will become 62. So that will be and we have seen that in NWP it has the great impact of the RSRW data. So then pilot observations also, that we are also we are increasing, that will be taken 4 times a day. And then apart from that, it is the radar, which will be giving a 3D volume scan data, and that when it will be covering whole India. Now nearly more than 43 radars are covering whole India. Still some gap areas are there, when it will be more than 60 radars all over India. So that will be nearly covering 3D space up to 3 to 5 kilometer height. So that will be giving every 10 minutes continuous observing information. And it is now, that will be the challenge for the NWP people, rather, to utilize that kind of information, and every 10 minutes that much huge information into the system. And so, and as it is of the 10 minutes, so it can give information about nowcast scale to any scale if you want. So that's now up to the scientists, NWP scientists, how best they can use those observing system information. And then certainly that satellites is the best nowadays for the NWP system, but still we have very less number of satellites in terms of scatterometer covering our region, so that we can get very good surface observations over sea. We still don't have any microwave information which can give very good information about the system. Any cyclogenesis is taking place anywhere, and then 3D structure of that system. So all those IMD is working, and certainly that our future program will be targeted to for better remote sensing observing systems, and as well as dense surface observation network.
Thank you, Dr. Anand, for elaborating the IMD's plans for expanding the conventional observations. So from atmosphere, we will go to ocean. So we have Dr. Sudhir Joseph from INCOIS. So we know that ocean observations, both in situ and remote sensing, are crucial for operational NWP, as all the operational NWP centers are moving towards the coupled NWP system. But currently, if you see the ocean in situ observations, they are limited to those from buoys, ships, and Argo floats, etc. So, what measures can INCOIS take to increase the quality and quantity of ocean observations, particularly over the Arabian Sea and Bay of Bengal, and their real-time dissemination? And one more question: what, since you are running many ocean models at INCOIS, what are the plans for the assimilation of satellite observation, particularly the surface salinity measurements from satellite to initialize your ocean models?
Thank you, thank you, Indira. In fact, the observations for operational oceanography, it started with means large scale with on the coming up of Argo system, which was started none other than Dr. Ravichandran, who is sitting here at INCOIS, and that is kind of large scale observation system which is available today. However, because of the COVID, there is a big dent, and it's just the target number is like 150 Argo floats per at Indian Ocean, which is to be maintained by the Indian Ocean rim countries, including India. And India has committed something like 50 floats per year we will deploy. But because of this various constraints due to COVID and other things, it was not happening. But recently we have restarted that. And last season we have deployed something like 40 plus. Now our plan is to continue with 50 floats per year. That is there, and apart from that, we have also commitments for tide gauge. But it is not only INCOIS when it comes to oceanography. It is NIOT also does the deployment and the maintenance of observations. So we have partnered between some of the observations for operational oceanography, like wave-guided buoy, tide gauge network, and some of those buoys are only maintained by us. So that we are continuing for the operational oceanography. And we have seen that there is a large impact for the, many publications have come up the impact of this deficit. And it has a strong impact on operational oceanography. And apart from that, what you are asking about the salinity assimilation, that in fact, recently we have experimented it in HICOM. It was showing impact, but the real-time availability of satellite salinity was an issue. But now we have some with 1 or 2, 3 days lag we are able to get. So we are trying to do that. That is in the process. Thank you.
Thank you, Dr. Sudhir. So from the conventional observations, we will go to the satellite observations, space-based, to Dr. S.P. Agarwal in ESAC. So, sir, if you see, we have space-based observation that contribute more than 80% in our data assimilation. So, even if we are telling we have the conventional observation like radio sonde, buoy observations, ship observation, but in the data assimilation system, more than 80% of the observation we are using is from the satellite observation, particularly the radiances and the atmospheric motion vectors, and they are very important over ocean and the desert region, the data sparse region where we are not having the conventional observation like radio sonde and AWS network. So, what are the ISRO plans for the expansion of Earth observations? As you know, we have the 3rd generation geostationary now, and we have the scatterometer mission also. So, what are the ISRO plans for the future, like 4th generation and the microwave instruments like that?
Thank you, madam. First of all, I would like to congratulate Indian Meteorological Department for completion of 150 years, as well as that NCMRWF for this 30 years of NWP, which is very, very important. In fact, as far as ISRO is concerned, we are providing the data. Dr. Mahapatra in the morning only, he has spoken a lot about what are the satellite they are using. But look at this that emerging trend. So I would like to start from our recently launched satellite. Then I will go to the next future generation satellite. So ISRO in fact has ensured continuity of space-based meteorological observations at the current scale, like the INSAT 3DS, which we have launched in 2024. It has a, it is like a 3D only, but has a better sensor performance. OceanSat 3 satellite, which I want to highlight here. It has a advanced sensors like OCM 3, which is having 13 band. Then SCAT 3. Just now you were talking about wind vector. So we have 2 satellites. One is a dedicated satellite for entire world, and that is a SCAT satellite. That is a scatometer satellite which provides the wind vector of entire globe. Nevertheless, in Oceansat 3, we have a satellite of SCAT 3 of Q-band that also provide the wind profile of the ocean. Then another one is that which is also very very important to understand the future energy balance, that is the sea surface temperature monitor. It is a two-channel sensor which provide the sea SSTs. So you know that these are the information which we get from the satellite with improved way. ISRO has been trying to improve the spatial, temporal, spectral, and radiometric resolution further in upcoming missions like GISAT-2 satellite and Trishna missions. You may be aware about ISRO CNS mission. The GISAT will have multispectral capabilities and also hyperspectral capability. If you look at the multispectral capability, it will have what you call LWIR, long wave infrared, and visible near rate infrared. But also we are going to have a hyperspectral capability in VNIR as well as the short wave infrared. So this will further provide lot data to the weather, and also that scanning type, if you look at it, the resolution is 50 meter, which is very very good. It is going to help a lot, and such high resolution data over space and time could be a game changer for meeting the data requirement for assimilation in numerical weather models, as there is a scarcity of the data, as you have already suggested. But let me come to the future generation. ISRO is planning, now it is a planning stage only, not yet approved also. We are planning a fourth generation. Now we have INSAT 3D, 3DR, 3DS. Yeah, so with the fourth, with MOES of course. So in fact, this is another thing like collaboration. In the morning we were discussing, and I'm really very much thankful to Honorable Secretary of MOES. I have attended few meeting with Chairman ISRO, with Honorable Secretary also. He is so proactive in space. Thank you very much, sir, for supporting space and ISRO. So always we are in discussion with, and fourth generation meteorological satellite is expected to boost this observation further in advanced imaging, having mesoscale observation probably at every 30 seconds. This is what we are targeting, sir. You are aware about it. Along with this, hyperspectral infrared sounder will provide high resolution vertical profile of temperature and humidity for assimilation into the model. There has been a long demand for space-based lighting detector, which is expected to be there in the fourth generation INSAT satellites. So these are the new things are coming up. One more thing I want to highlight, since I am from Northeastern Space Application Center, and we are also predicting this, we are also having HPC and all. There is no match with the IMD or NCR, but we are still doing for Northeastern region with the high resolution of 3 km by 3 km grid. Now we are planning for 1 km by 1 km grid. Now with the help of IMT Pune as well as with the help of NRSC, we are predicting this, we are now casting the lightning. And I am happy to tell you that this year we have given more than 75,000 alert for lightning in Northeast region. So just for information you that yes, at NESEC also we are doing lot of weather forecasting and lighting forecasting. I hope I have given answer to you.
Yes,
Thank
sir.
you very much.
Thank you. So now we heard about observations. Now the thing is now how we can use these observations in the NWP, particularly in the data assimilation. So we have the satellite data assimilation expert, Dr. Randir Singh. So you heard said that NESEC director, he was still, it is 80% of the data we are using from the satellite. But if you see that 80% is only 10% of the data we receiving. So what are the new developments in using all sky and all surface satellite radiances in the assimilation?
Thank you, Indrani. And first of all, actually, I joined Dr. S.P. Vyas in congratulating both IMD and NWP for celebrating its 150th anniversary and then 30 years of NWP, operational NWP services. And thank you for taking us on board also in this celebration from SAC ISRO side. So coming to the point about the utilization of satellite data, actually if you see the problem of data assimilations and the observing system. So the data assimilation basically is actually generally formulated on basis of Gaussian error distribution. So if you are non-Gaussian error distribution, so minimization and other data assimilation technique may not work optimally. And in operational chain, you cannot, take that sort of like guarantee that everything will work, because operationally you have to deliver in a certain time period. So you cannot sort of like put any non-linear observation which is related with the non-linear with sort of radio transfer model. Because when you talk about radiance, then you have to have a radio transfer model. which has to sort of get the radiate to transfer model, simulated radiance, then you have to compare with the actual observed radiances. And you know that most of the cloud and precipitation processes in NWP system are not well parameterized. I mean, there is always sort of mislocation of the sort of heavy rainfall or sort of magnitude wise as well as location wise. So if you put like, I mean, radiances and there is a cloud in some other place, so model actually data assemblers will force to change the NWP system in such a way that it may blow. Because those Jacobian and other things they are not that continuous function of your latitudes. So in microwave, the problem is slightly linear when compared to the infrared. So there you have like if you have cloud, liquid water, and rain, distribution. So you can slightly simulate radiances in a better way compared to IR. And microwave now, actually, if you see last 10 years or 1 decade, we have a lot of success in assimilating the microwave radiance in even cloudy condition. But as far as infrared is concerned, because infrared gives the cloud top informations. Cloud top is only very small part of the top of the cloud, which may have certain water droplet or ice. And the entire structure below the cloud has to be actually generated by the covariance matrix. That again is not well. If you go for like convective scale or precipitation situation, always background error is not well formulated because model has large error in simulating those things. So that is a still challenge, but in R&D we are doing a lot of research. I mean, how to actually assimilate infrared radiance in cloudy condition also, and a lot of R&D actually activities are going on. But in operational scenario, only microwave as far as operational chain is concerned, microwaves are now well established, and we are assimilating microwave radiances in cloudy and this clear sky condition. Then again problem comes over land and ocean, because land again has a lot of heterogeneity. And when you talk about land surface peaking channel, so you must have a lot of what you call emissivity as well as land surface temperature, because you have to segregate between signal. So emissivity is it's not well known, because surface is quite heterogeneous, and if you go at a much smaller scale like convective scales, it is again a challenge to get the emissivity at that scale. So there is a problem. If you assimilate surface channel, then again it may have certain imbalance problem in the model. So what we do is over land, we generally assimilate the upper tropospheric peaking channel, where surface contribution is smaller. So that again actually reduces the amount of satellite data utilization. But if you see the progress, we are actually progressing. So I think coming maybe one more decade, infrared radiance also may be assimilated because of the development of nonlinear data assimilations like particle filters or ensemble modeling. So those things actually, I think within 1 decade, I'm hoping that. And also another thing is your radiative transfer model is also improving for the cloudy condition simulation, because we have a lot of observations from the satellite, like cloud liquid water or microphysics. So we can actually validate our radiative transfer model also in cloudy condition simulation, whether it is working well or not. Earlier we actually didn't have those sort of observation. How to validate your radiative transfer model, because we don't know the basic state of the atmosphere in the rainy condition. So that is also another plus point, that radiative transfer models are actually also improving, and our representation of the cloud and precipitation processes in NWP system are also improving. So when you compare the simulated and actually observed radiances, so your representativeness error will be smaller, so that you can sort of constrain your data assimilation algorithms. So in that way, I think we are progressing, and soon, as Dr. S.P. Vyas told, we will be having observation of the sub-kilometer scales, like our own 4th generation. We will be having observation of something like half a kilometer. Visible channel radiances are also now being assimilated over the ocean. So in future, I think we have a prospect of good future, and observation-wise as well as development in data assimilation also. So we will further actually enhance the utilization of satellite data in coming future.
Thank you. So the 10% utilization of satellite data means, it doesn't mean that the data is bad. It is due to the constraints in the data assimilation system.
Yeah.
And we are developing in both the ways, in observation technology and in the data assimilation.
Yeah, and
methods.
another thing, just I want to point out, in southern hemisphere, if you go, we are actually having more utilization because of the ocean. But our northern hemisphere, the competition between actual conventional satellite actually is very small. Satellite has to do, we have to do a lot of efforts to actually match the conventional observation quality with satellite. So that is also another challenge. That is again because of the land surface heterogeneity and other things.
Thank you. So next question is to Dr. Vijay. So if you see that we have lot of data. Nowadays the volume of meteorological and oceanographic observations has increased many-fold compared to the past decades. Not only the satellite data but the conventional data also. And this is due to, as he already explained, this is due to the developments in the observation technology and satellite meteorology instrumentation, etc. So the effective use of existing observations and the new observation, that is a challenge, especially if we have the crowdsourcing observation, that is that it is not a standard observation like it is not according to the WMO standard. So what strategies do the operational NWP centers adapt to handle this observation, and what are the developments in DA means we have to do what are the developments to incorporate this non-standard data?
Yeah, thank you, Dr. Rani, for an excellent question, and thanks for the opportunity to join this excellent panel. I'll answer the question in a slightly different way. The first question obviously is, do we use our existing data sets efficiently? And I think Dr. Randir already explained we are having a lot of issues using the existing data. You also mentioned about anchoring using the conventional data to make better use of satellite data. And now we also mentioned about the crowdsourcing and the private industry getting into CubeSats and so many new observation types and new platforms coming online. So we are only going to see this kind of explosion of data availability in the future, not only for atmosphere but also for ocean, other cryosphere and land surface and all Earth system components. And that makes the data assimilation job much more harder. Obviously, it is constrained by several aspects, including the timeliness in terms of operational NWP. But I think I see this as a challenge as well as an opportunity. We have, I think Dr. Mike Farah in his talk today mentioned about joint effort for data assimilation integration, also known as JEDI. JEDI has some beautiful concepts in terms of how to improve the use of existing observations, like they have developed something called IODA. It's an interface for observation data access, which allows non-standard formats that you mentioned, including the crowdsourcing data, can be easily interfaced to our NWP systems. And the second point is using the emerging techniques like the artificial intelligence machine learning so that we can thin the satellite data more effectively. We are kind of randomly discarding data without even understanding what we are throwing away because only 10% or less of the existing satellite data can be used. But now think of using some of these machine learning techniques so that you can take most useful content of that satellite data. And then the third point is the co-located observations for the Earth system models is extremely important. You need to have observations that are meant for our atmosphere also can be utilized by the ocean and vice versa. So that interface need to be measured more effectively. That means the new observing strategies should pay more attention to the co-located observations, and that and the flux measurements will take much more demand going forward. So those are still the gaps that we need to address. And we also heard about the non-local, non-linear data assimilation concepts, but also some measures like the scale-dependent localization that allows us to assimilate more data depending on the scales of assimilation. We also have multi-scale data assimilation techniques that are coming in that takes into account various dominant factors within the patterns that we are trying to resolve. And as we improve the science, as we improve our models, our cloud detection algorithms will be much better so that we can position our satellite data sets in much more efficiently. And lastly, we also have these radiative transfer models that are getting better and better in taking care of those discrepancies between the model fields and the observation fields. So this is going to be a continuous advancement that needs to happen. And as the ISRO scientists were mentioning, we have future generation satellites coming in. Billions of dollars are spent in developing those technologies. A little fraction of that, spend it on data assimilation, it will have a long way to use those data sets much more efficiently. And no need to worry about after the fact, like, you know, we will have always a pressure when a new instrument is designed and launched. The pressure is on the operational NWP folks to make it use and show the impact. And a lot of times, probably you are all aware of those who are in operational NWP, a lot of times the very first attempt will be a degradation of your existing forecast because we are creating an imbalance by using something new that was not known prior to. So a lot of testing is needed, a lot of evaluation is needed, and data assimilation scientists are very scarce. They're very hard to find. So the the academic sector need to pay attention to that problem, generate more people who are interested in data assimilation so that we can make better use of the existing observations as well as the future observations. Thank you.
Thank you, Dr. Vijay. That I like that point because we have to encourage more academic people in this data assimilation, because I have seen very few people in the academia, they are doing the data assimilation. Thank you. So, next question to Dr. Ashish. So you know that almost all the world's leading operational NWP centers are moving towards the kilometer scale modeling with various Earth systems. Okay, so almost all the NWP centers are moving towards the kilometer scale modeling with almost all the Earth system components like atmosphere, ocean, land, biogeochemistry, etc. So what are the challenges in the data assimilation when we move towards K-scale modeling?
So thank you. Good afternoon, everyone. So it's a very big challenge already. These are discussed, but here is a K-scale model. We are more interested to K-scale model, and NCMR already started that work in 1 kilometer WRF and UKMETAP is also. So challenge is here when the system works for the most common thing, but when extreme and rapidly change the convective system, then the analysis is not captured. What are the challenges here is I will just discuss about the 4 challenges for K-scale very briefly. So one is observation. How frequently, how spatially, temporally we are taking the observation. If you are going to K-scale model, so we need 1 kilometer at least the observations. And when we are 1 kilometer observations, then we have to vertical spacing should be 250 meter. And time within at least boundary layer. And then to the every 15 minutes. So this type of data is required. Then when it is this type of data, then we have to think about what is the observation operator, because we are adding crowdsourcing observations and non-linearity, which are not quality control and all these things. So how we have to make this observation operator of this advanced, if you have a satellite and 15 minute, 30 second data, and we have to develop our observation operator. Then second challenge will be our complex quality control package. We have to not to adopt that what we are adopting nowadays is the quality control. So we have to develop our complex quality control packages. That is very essential. We are getting lot of observation. Then what is your quality control? We cannot add all these observation whatever we are getting from. So in the quality control, if you see this radar data, we are getting 10 minutes. We are also started the assimilation, radial velocity, reflectivity in the convective permitting DA. So challenge is when you are a K-scale model, whether the parameterization scheme, whether it is producing that amount of heavy rainfall, extreme rainfalls or extreme things at the time of analysis, first case. If not, then whatever observation we are giving, then we have innovation. That is a standard threshold. So when the innovation will be observation minus background will be high, then automatically model will be rejected, whether it is observation is good or bad. So how your model is evolving, that also be aspect, even though we have a good observation. The second challenge is the handling the multi-scale scenario. Because this convective scale and all these things depend upon the your synoptic mesoscale feature and convective. So how you incorporate this synoptic information in your K-scale model, and how whether will be consider all these synoptic meso and convective. This is an open challenge for the data assimilation as well as modeling sector. So in this case, certain development is happening, blending. We have a large scale, so we will blend that information to the small scale features in the regional model. That is an open challenge and we have to work on that. Then third question is non-linearity of convective, whatever Dr. Vijay is saying, we have a lot of observation is coming. How is non-linearity? How the model is accepting that? So we have to develop our data assimilation flow dependent, background error and flow dependent and observation, all these things. So this some aspect flow dependent is developed in the global model, but it is not exactly applicable to the K-scale model. And that is a different scenario which is happening in the K-scale model convective permit.
So third one is the systematic error in the model representation of hydrometers. How your hydrometers is represented in the initial cases. But I explained how your O minus B, how the threshold will be adjusted and all this. So these are the major challenge in the K-scale modeling. So even though we are going high resolution observation, all these things, so we have to think about how we will multi-scale processes, how to incorporate that multi-scale processes. Whether we will neglect and go to very nowcasting or small scale, or whether we include that synoptic scale features in the K-scale model. That is also opening challenge, how to incorporate in that. And furthermore, whatever developed in K-scale model over the extratropic that not be applicable to the tropics. We have to think about tropic India and all these things. We have to think about, we cannot adopt the same scenario to our tropics. So we have to have the more sensitivity, more whatever observation is coming, how it is being assimilated, and we have to make a sensitivity study, each observation. My request to the audience in this, so we have to develop our own dedicated quality control package, dedicated people for K-scale modeling, the quality control observation, because we are getting lot of observation from different sources. So quality control is a major issue for the assimilating the K-scale. So these are the aspects we have to handle and challenge for the K-scale model. Thank you.
Thank you, Dr. Ashish. So now I thank all the panelists for their valuable time. And so then now I will invite. So now I will invite questions from the audience.
As you all told that land surface plays a very important role, and when you are doing coupled models, obviously you cannot neglect the land, whether even in nowcasting or short range. So what is the status of observations, and what is we are doing on that scale? Because everybody told about atmosphere and ocean, but what about land? Land is soil moisture, soil temperature, which is very highly nonlinear, or the land surface vegetations and so on. So what is the strategy in that direction and for assimilation? So that is one question. Second question is that we are going to have so many radars. So whether we are going to get rainfall also derived more accurately, because most of them will be Doppler type of radar. So rainfall is one of the things which are the most heterogeneous, like soil moisture. So what is the things we are doing so that maximum use of that thing, even if not model, in general applications also? Thank you.
Sir, I'll answer first land surface one, then radar IMD can explain. So, yeah. So this land surface, NCMRW had developed this land surface extended Kalman filter in the UKMet model, taking the Joule's system. So in that we are assimilating ASCAT data assimilation. Already we have operationalized that in our land surface system, global and as well as regional. Now we are moving towards SMAP, soil moisture. Data, we are using the satellite data, but the observation, the 2 meter temperature and a 2 meter humidity, also we are considering as a pseudo observations. So, yeah. So, soil moisture, it is need so now we are planning to we have submitted one project to soil moisture to modeling to measurement to modeling soil moisture. So that brainstorming will be IITM Pune 26th November. So we are planning also all over, So in that Dr. Krishnan will be comment on that. And
there is a proposal that is being submitted to MOES to develop a very high resolution soil moisture data set by using the IMD. They have some in situ observation, plus the some Cosmos network, plus we have the NISAR satellite now. So we are aim is to get a field scale soil moisture, typically something like 500 meter. So that is a kind of product that we are aiming, and so we are going to have a meeting on 26th to discuss this. So this will be submitted by different universities, IITs, and also US partners, and with IITF, and also IMD and NCMRW. Not only observations, how to use that in the model. So measurements to model, how to make this data. So that is the plan. And so no such product exists as of now. So this will be discussed.
And we have Dr. Amarjyoti here. She can come up with her presentation.
Precipitation. Yeah, the radar-based precipitation. Yeah, we are having a national level product where we are blending the radar and satellite product. It is at a very high spatial and temporal resolution. So once the IMD network will be enlarged, so definitely we'll have all the radar precipitation will be blended. So maybe the challenges will be at the foothills. I hope with the polarimetric attenuation and all the corrections and all, the radar data will be very useful at the temporal resolution scales which everybody are expecting for nowcasting and other perspectives. Thank you.
Thank you, Amar.
This is a short inquiry to Dr. Sudhir Joseph. In the coupled model, we need to predict SST accurately. For that, we need to have good idea about the turbulent heat fluxes across the ACE interface. I remember a few buoys in the Bay of Bengal were fitted with these direct flux measurement sensors. Can you please tell us what is the current status of those measurements?
In fact, as part of Rama, they were there, but as of now, we are not getting those fluxes. That is getting fixed.
Direct fluxes. So that is only one buoy has been deployed for a direct covariant fluxes to measure.
Okay.
In Bay of Bengal, they have measured for more than 1 year, and the same buoy is going back to US to refurbish, and it will be deployed in the Arabian Sea.
Okay. Thank you. Thank you.
He was talking about covariance. Okay.
Yeah.
There were some short wave and other long wave fluxes from Ramabu. Those are. Yeah, that was there earlier. Operational. I was thinking about operational.
So thank you. I just maybe since we are talking about observation and what are the observation we need to assimilate for the better forecast. I think when you are talking about observations, we need to have, especially in our region, where we need to observe, what we need to observe, both on land and ocean. So for that, I think we need to do some sensitivity studies or observing system simulation experiment. I think it is imperative that we need to do so that we can have a observation judiciously we can put in place in spatially. That is number one. And also we need to have a temporal thing also, whether we need to monitor temporarily also. Suppose a radio Sunday we are making twice in a day. Is it good? Whether you will be able to resolve diurnal scale. If it is not good, then we have any plan to go for to resolve the diurnal scale. We have any other requirements, or we need to have any profiling or anything apart from sounder or anything. So we need to think about that way. And also its impact has to be felt by the model so that we can have a better forecast. So this is one important thing. And second thing is, of course, observing system in the IMD. I think the main thing is, apart from conventional AWS, radios on air, radars and other thing, I think the very important feature is, I think we are planning to go for profiling. Basically the wind profiling, wind profilers, as well as we want to have a radiometers, so that we can have a continuous observation. That is a very important component which we are planning in the mission motion. And For the ocean observations, apart from mood buoy, drifters, as well as Argo floats, and also it has been planned under a deep ocean mission, it is also planned to operate multiple gliders, so that wherever the Argo gaps are there, so the glider can move and acquire the data, so that can also can be assimilated. So these are the efforts in this.
Yes, sir. Actually, we started the OSSC for the wind profiler, then for the fourth generation INSAT satellite, and also for the IMD that expansion of radio sonde, that every 200 kilometer, if they put the radio sonde, what is the impact in our assimilation system, that we already initiated. That is FSOA also for our forecast sensitivity to observation impact. That also shows what is the impact of each type of observation in reducing the error in the forecast. Yeah. Yes, sir. And actually, I saw recently Dr. Rendir, he published a paper on the OSSC on the GNSS RO over the Indian region.
Yeah, just what actually Dr. Indrani said, just to add on. Actually, we have done some sensitivity for GNSRO. So what actually we have found is if you have something like every 150 kilometer grid box, one occultation every 6 hours. So your accuracy will be improved by something 20 to 30% for extreme rain events. So it will require something like 700 LEO satellites. I mean, at LEO platform. Yeah, GNS. Yeah, GNS is like per day is one, or every 6 hour one, or per day one occultation. Yes. Yeah, that's spire. Yeah. Yeah, ground base is different. See, one is the radio occultation, that's give the profile basically. Another is the ground base, means the integrated water vapor. So if you have both, because this occultation actually won't give the boundary layer sort of information. Yes, so if you combine both, so it will be a very deadly combination over the tropical region. That is one thing. Another is if you go like conventional remote sensing, like your infrared radiometry or microwave based. So if you go for GNS kind of thing, where precipitation and they are insensitive basically, you can get profile even in the rainy condition. So that is the actually future. GNS is reflectometry over the ocean to give the wind speed, and also over the soil moisture also basically over the land, and the occultation. So if you combine this and then you get wind from some, let's say AMV or wind lidar, so that is the actually future. Yeah, reflectometry will give over the ocean surface and soil moisture over the land. So that is that. And another thing what we have done is the wind profiler. So if you have boundary layer wind profiler within 4 kilometer of the surface, that will have much larger impact than your upper troposphere. So we can also sort of deploy the ground-based wind profiler.
That is what we are planning.
Yeah,
that
study we have already done, so results are available. But yeah.
Wind is the most important thing in the equatorial and tropical region than the temperature.
Yes,
the
yes.
temperature is almost a smooth one, but maximum variation is the wind.
Yes, yes.
So we always demanded whether from satellite we can have a wind profiler so that it can cover not conventional area but non-conventional ocean area.
Yes,
Sir,
actually
AOLS, that satellite is there, that is giving the profiles of horizontal winds that we used, and under mission Mausam we are planning another repeat AOLS repeat with that the original developers, that is also there. And I heard NIOT is also planning the buoy based lidar, so that we will get the observations over the ocean also, particularly wind.
Yeah, thank you very much. I just want to add something what Secretary Saab has already told, that apart from the OSSC and experiments, etc., we should also plan. Now we are coming up with, at present we have got 40 radars. As per the supply order issued, we will have 72 radars total by end of 2025. Then under Mission Mosam, we are ordering 53 radars. So total it will be around 125 radars. So we should plan accordingly how to assimilate 125 radars, how to archive, how to retrieve, how to quality control this data, how to go for mosaicing this data, for utilizing all types of models, nowcasting, short range forecasting, cyclone forecasting or specific severe weather forecasting. So different types of applications also have to be developed based on the NWP assimilated with the radar data, etc. The second point I want to say that wind profiler. We are going for 25 wind profile, 25 micro radiometers. We are getting 10 wind profilers. At the same time, 1,30,000 automated stations that are coming off at the panchayat level. So all these huge data, we should find ways and means to quality control and to utilize it in NLP models, so that we can have the better accuracy, better lead period, and also we should have the better resolution also at present. So perhaps we are planning towards that. So this is with respect to this, whatever additional data we are getting apart from this. So as Secretary Saab told, yes, you will have almost every second data from wind profiler and micro radiometer. 3D profile will be there, 3D profile will be there. So we should utilize that. Now I will come to the satellite. The satellite data, if you just look at, so as a member of the international community, we participate in different countries. Our satellite quality, data quality is not so good. People outside do not appreciate and do not trust, they do not utilize this data. So we should have more effort to ensure the quality of our satellite data, be it the temperature profile or be the wind profile what we are getting. And if you compare apart from quality, if you compare the resolution of the current satellites with the satellites available even with the KMA or JMA, or it is with UMETSAT or with US, we are lagging behind. We are still at 1 kilometer resolutions, where people have gone up to 500 meter resolutions. And so there are enough scope to improve the satellite data and satellite products. On the other hand, I just want to, Agrawal Saab is not here. I feel very sorry to mention here. Why should ISRO issue weather forecast to public? Is it the nodal agency to issue weather forecast? Is it their mandate to issue weather forecast? Why should they issue lightning warning or lightning forecast for Northeast India? Is it serving the people? When IMD is issuing the service, when IITM is providing the Amini Airport, if information is going through this, if another source is being provided, people will be confused whether disaster manager will take action based on IMD or based on ISRO or based on third party. So it becomes a little, among the government agencies, it becomes a little, I will say, ridiculous. So I will request, let us confine ourselves within our mandate. If we are going beyond our mandate, it may create problem. And we are willing to collaborate, we are cooperating. Whatever development has taken place, the best example is the relationship between Space Application Center and IMD. Entire development goes on smoothly, and we adopt it, and also in NWP. We work together to ensure that CMV is validated. Both IMD and NWP work with them. And after the 2013 INSAT 3D came, after 6 years, the wind data could be utilized in our model. But now also we know what is the status. So therefore, I will request that let us not venture into the area where somebody else's domain, and let us work in our domain to improve our products for utilization in others' domain. So we have had a very good collaborative relationship. Let us not spoil it by that way, just like the private parties venturing into the government domain. That's what I just put forth my views. Thank you.
Thank you all. So I thank all the panelists.
Actually, when the question of ocean observation is concerned, came to me, I was wanted to ask about one thing. So whether the ocean observation at a particular location, the distribution of ocean observation, how sensitive it is the atmospheric models. That is there any kind of OSSC for the regarding ocean observation for the atmospheric model? Because in ocean there are methods to do that for identifying the optimal network for Argo. There was an effort earlier and it was done.
Yeah.
But similarly for the ocean observation, which is going to the atmospheric model, is there any kind of
Actually, we have Dr. Sumit here. So couple model, yeah, we just made it that experimental run we are doing. So then we will come to know that what is the impact. Like FSOI we are doing for the, where is Sumit? For the atmosphere, the similar way we will come out with the ocean observation also.
I think we can integrate that also together when we design the optimal, which was Secretary was. Okay.
May I have a comment? Yeah, here. Yes, just one more question. Really more of a comment and a question. As you pointed out, you're looking for an optimal distribution of all of your Earth system observations, whether it's satellite, surface, ocean, land. We can't afford all of them. Especially satellite data is ubiquitous, but it's also very expensive. So one of the problems we're having in the U.S., I assume you have the same problem, is we typically don't have a integrated, validated, uh, objective, observing system experiment to demonstrate what the most optimal observations we need. So we spend billions of dollars launching satellites, millions and millions of other observations. In the end, I don't know whether we're spending the right amount of money to get the best prediction. So one of the other problems we have is to run those observing system experiments. We have to use the same exact people who are developing our models, and they don't have time to do it. We don't have the HPC to run all those model runs. So looking to the future, as you have your big project that's coming up, a lot of that money is going towards new observations. Are you planning on trying to build in part of that new funding to do these sensitivity studies to really demonstrate what the right observation mix is? Also, you can't, it's like if you only have 10 million more dollars to put in observations, where would you put it? We can't answer that question, can you?
Yeah, actually in our mission Mausam, when we were discussing the DPR and all that, it is the first thing is that we have to do the observation system simulation experiment for each type of observation that IMD and IITM are planning to implement. So that we are planning, and we started the OSSC for the wind profiler, that what IMD is planning, and for the radio sonde also, and the 4th generation that is similar to AHI and ABI. So that also we initiated. Then other experiment, other observation like crowdsourcing, all those things, that those are in the pipeline. So slowly we are doing. So that I agree with you that even if we are spending lot of money for the observing system, we may not be using all the data in the assimilation system. But there are other applications like extreme weather nowcasting, all those things are there. Thank you. All the panelists for their time and their valuable sharing the experience. Thank you.
I would like to thank the moderators, Dr. Indira Rani, rapporteur Dr. Upal Saha, and all the panelists for carrying out a very engaging panel discussion. I would call upon Dr. Raghavendra Ashrit, scientist GNCMR WF, to present the panelists and the moderator with a token of our appreciation. Mr. Vijay Talapragada. Dr. Randeep Singh. Dr. Sudhir Joseph. Dr. A.K. Das. Dr. Ashish Rautre. And Dr. Indira Rani.
Thank you.
Now we move on to the second panel discussion for today, which is describing the future roadmap for modeling. The moderator for this session is Dr. A. Jayakumar from NCMR-WF, and the rapporteur is Dr. Anurose TJ, also from NCMR-WF. Dr. Jayakumar and Dr. Anurose.
Welcome back to the new session. I think morning session we already celebrated and we already witnessed the achievements in the last 30 years. Now we need to go ahead, and the next session is about the future roadmap for modeling. So first I need to invite Professor U.C. Mohanty, Dr. Krishnan, and Professor H. Chandrasekhar, and Dr. Hugh Lewis from UK Met Office, Professor D.B. Bhaskar Rao, and Dr. Saji Mohandas from NCMRWF, and Rapporteur Anu Rose from NCMRWF. With the time constraint, we know that it's running very delayed, so sorry panelists, I will give a very short bio. I think you don't mind if I give a very short bio about that. And starting about the panelists, from Professor U.C. Mohanty is a distinguished professor at Shiksha O Anusandhan University, and is a very eminent scientist and a recipient of multiple awards. And his domain of expertise is in developing high resolution model in predicting tropical cyclones, rainfall event, thunderstorm, and the tropical storms. And as mentioned in the morning, in 1994, he's the head of research divisions of NCMRWF, and he and his teams were the first in India is responsible for the implementation of operational NWP in India. So, sir, welcome, sir, for this session. Yeah, next one is our Dr. R. Krishnan, sir. He is the director of Indian Institute of Tropical Meteorology, Pune, and he's a developer of IITM Earth System model, and which is participated in the coupled model inter comparison CMIP 6 for the IPCC 6 assessment report AR6. So welcome, sir, to this session. Next one is Professor A. Chandrasekhar. He is the outstanding professor, Dean of Earth and Atmospheric Science Department of Indian Institute of Space, Science and Technology, Thiruvananthapuram. And his major domain of expertise in the numerical modeling of atmosphere, data simulation, mesoscale modeling, and the land-atmosphere interactions. Welcome, sir. And this was Dr. Hugh Lewis is the head of the regional model evaluations and the development area at UK Met Office. And he is the UK lead of WCSP, that is Weather and Climate Science for Service Partnership. And his area of research is in development of kilometer scale region coupled model and the exploration of application of kilometer scale models on global scales. So welcome, Hugh Lewis. And next one is Professor D.B. Bhaskar Rao. He is the Professor Emeritus of Andhra University. His domain of expertise in the tropical cyclone predictions, convective parameterization, and the cloud microphysics. Welcome, sir, also for this panel discussions. And finally, not least, Dr. Saji Mohandas, my mentor, and he is the group head of model development of NCMRWF. He has a vast experience in the development of global and regional model, convections, and microphysics. So that is about our panel. I think I will put some questions, I think, and starting with Krishnan sir, as he is the expert in the climate modeling. So, sir, which is having the predominant role in improving the skill of NWP model? Is it adding more complexity in the model, like you did this in the interactive aerosol scheme, land and atmosphere coupling, cryosphere, water cycles like river forcing, groundwater, or ocean biochemistry? Or is it an increase in the resolution in the horizontal and the vertical? So as per your this much of vast experience, so which can we give a NWP prediction skill improved? Yeah.
I will not give a very direct answer to that question. So one thing is, because what we are realizing, we have reached certain skill in the weather forecasting. Now when we see some of the events that are happening, these are compound extremes, they say. So we had this 2022 in Pakistan, heavy rainfall and flooding. And if you see all the antecedents, of course there was a monsoon depression that brought a lot of rain, and there was water vapor transported from the Arabian Sea, from the Bay of Bengal. And so with climate change, the ocean temperatures are increasing, so more evaporation, so more moisture transport will strengthen into those precipitation regions. And also, prior to the monsoon season itself, during the pre-monsoon, the temperatures had gone up in the upper Indus Basin. So temperatures had crossed more than 40-50 degrees. So the ice starts melting at that time, and the glacier starts melting. So it's a compound extreme. And so when the heavy precipitation occurs, the flooding increases. The floods are exacerbated. So when you start seeing these impacts, you need to really look from Earth system perspective, not just look at only the atmosphere. I think Secretary aptly mentioned this morning. So when we are looking at the weather problem and its impact especially, we have to take an Earth system approach. And that would be my one of the points I want to make. And second thing is, and of course each one, atmosphere has a heat capacity, land has, ocean has, they're all different heat capacities. The time scales of response are different. But when you want to address this problem, you have to really look at from an Earth system perspective. And recently, very recently, just few days back, there was a paper in BAMS, and it is called Earth System Reanalysis by Detlef Stammer and people. They have produced this wonderful paper. So their logic is basically just going on increasing the resolution. It will take you up to a certain point, that's all. And no matter how much you increase the resolution, biases are going to be there compared to the real world. So when you compare with the real world, biases are going to exist no matter what resolution you do. So then how do you deal with the problem? How do you improve the models? So what they are proposing is, they are telling if you want to do the Earth system reanalysis, you have to use a model of sufficiently high resolution. And then you also have to have all these observations to do a data fusion. You have to bring in ML techniques to improve model physics. For example, subgrid scale process. Because if you are just going to conventional way of improving the physics in the model, you may take forever. You may improve in one place, but some other place it may not work. And the errors there will propagate. So how fast your errors are going to grow. So they're all interconnected. So that you have to keep in mind. Here I may have a perfect one-dimensional model, but you're putting into an fully interactive three-dimensional model where transports are involved. So your errors are going to propagate. So the only way is they are suggesting is, you have the data, a lot of observations from satellite, in situ observations, radars, and then bring in the data fusion techniques like machine learning in your data assimilation, improve your initial conditions, reduce the uncertainties in your initial conditions. That is going to be the way for the improved prediction. And so they're not only advocating for the coupled Earth and ocean and atmosphere, they're also telling, bring the cryosphere and the biogeochemistry. So it's an Earth system reanalysis with data assimilation and using the observations, enhance the utility of the observations, and bring machine learning to improve your initial conditions and the forecast, whether on the weather scale, on the seasonal, sub-seasonal time scale. So I think that makes a lot of sense to me. So up to what extent you will be able to increase the resolution, I'm not sure. So that is because it has computational complexities. So it's very nice, kilometer and sub-kilometer scale, it's very wishful thinking, but we have to be practical. So one thing is this Earth system reanalysis approach for the weather and climate prediction is going to be very, very important. That's what I think so.
Yeah, from the panel, anybody want to give any comments on the same questions, or you, Louise? So in the same questions where, as our MO is also, as we discuss about the mission MOUSM, we are also going for Earth system model with very high resolution of 3 to 5 kilometer. I think you already know that. So do you want to comment with the same response you given now?
Yeah. So for mission MOUSM, it will perfectly match, because the aim is to get a lot of observations, and Secretary was just also look at the vertical profiles of the winds and from the micrometer profilers, radiometer profilers. I think that will be very important. Plus all the land surface parameters like soil moisture And if you want to really look at droughts, or that's going to be very important. And so having all these observations is going to be very important. And because improving the physics in the model subgrid, it's going to take you forever. We can do that. That can go on in background. I'm not telling you don't do it, but that's going to take time. And so this ML methods are going to become very important with the observations. That is one way of improving the model physical representation of the physical process in the model.
Mention more about emulator and all. So we have one more session where the AML, where I think they are going to more discussion.
So actually, this one is related to the previous.
Oh, okay.
panel.
Yeah, actually, I think I need to continue with the same discussion. So next question is to Professor Chandrasekhan sir. As Dr. Krishnan is mentioning about going for higher resolution, where the scalability of the model in a computer is very important. So my question is the dynamical core, which is like the heart of the model infrastructure, and it numerically solves the fundamental governing equations and impact mainly on the scalability. So, but in the NWP community, like even mostly in India, we are more lenient towards the research and development towards the model physics. So whether our attention is slightly reduced in the dynamical aspects of the model, like the treatment of vertical or horizontal distribution.
Yeah, thank you. So my response would be like this. It is true that the dynamical core is an important component of the NWP system. Like for example, as you rightly mentioned, so the dynamical core is what is responsible for getting us the numerical solution from the basic equations, governing equations of the atmosphere, which we discretize. Of course, needless to say, as Dr. Krishnan mentioned, that the model physics, we all know that model physics is very important. The physical parameterization schemes are very important, and we have made progress, but as Dr. Krishnan pointed out, there is still a lot more progress to be done, and this would go on. Now let us look at it in a different way. I don't think that we can choose one over the other. Now both are important to me. So let's look at the dynamical core, for example. It is true that dynamical core research is considerably less in terms of the number of researchers who are taking it up compared with the people who take up, like sensitivity of the different model, physical parameterization, things like that. Now, if you look at it very simply, let's not take the full governing equations. Let's take simple advection equation. Now, if you want to take, now what I'm trying to say is when you discretize the continuous differential equation into a discrete set, like the continuous problem is made into discrete problem, even then some physical insights are required. For example, if you take an advection equation, now obviously if you are advecting moisture, you would want the advection scheme to be such that it should be positive definite, in the sense that I cannot have a result where the moisture can assume negative values. Okay, so this physical insight is there even when we actually convert a continuous problem to a discrete problem. Like for example, like we all know that Arakawa Jacobian, right? So essentially it was, what was done, he just discretized the continuous problem to a discrete problem, but then he kept in mind that there has to be some conservation properties which still have to be satisfied by the discrete problem, which was holding for the continuous problem. So that physical insight is automatically required. Even in discretization, physical insight is very much required. Now we all know that once you have the nonlinear equations come into play, then we have the nonlinear computational instability. One way of handling it is using the Arakawa Jacobian. Another way is look for Lagrangian system, Lagrangian equations which don't have the nonlinear terms at all. Now fully Lagrangian systems have their own issues, so we go for a semi-Lagrangian system. So essentially our progress is determined by some physical insight. That's what I'm trying to say. Like for example, we all know that this Galerkin methods were known for a very long time. Like they are known for similar to the method of finite differences, but they were never really used in atmospheric science until 1940 when the transform method came. Because they all know that this Galerkin method, they are much more accurate than the finite difference method. This is known to everyone. Because what we do in finite difference method is we approximate all the derivatives, the first derivative, second derivative, every derivative we approximate. and then we have an error associated with everything. But in a Galerkin method, you retain the number of terms in the expansion, and then your derivatives become exact. So obviously, we are ultimately all our governing equations are equations involving derivatives. So obviously, if you are going to use a Galerkin method, your derivatives are exact. So to that extent, it has to be a more accurate solution than your finite difference solution. So then obviously then once you have nonlinear terms which are inevitable in our atmospheric model equations, you end up in a situation where you have to multiply two series. And that's where we landed up in a problem until the transform method came out and provided us a solution, workaround solution for that. So what I'm trying to say is, even in discretization, there is always some physical insight which goes into it, and that really helps. So those discretization schemes which, like for example, the staggered grid. Like now we all know that why do we use staggered grid? Staggered grid obviously simulates geostrophic adjustment in a much better way. We have serious issues with non-staggered grid that everyone knows. So wherever the physical insights are really providing us a better discretization scheme, we should be going for it, and we are going for it. Yeah. Thank you.
Your response, I feel like I'm reading a basic of atmospheric science books where the Chandrasen sir books. Yeah, and obviously there are advanced methods, but in the operationally we use a semi-implicit, semi-Lagrangian method. We have to finish the model time within the wall clock time. But advanced method is good, and it have to be. I think in the panel, anybody wanted to comment on the like we know that in the unified forecasting system, all the NWP centers are more focusing on the improving in the dynamical core. That's why this question is very critical in that. Sir, do you want to add any?
Yeah, we know like I think this GFDL has a finite volume core, which is now it's most sought after. So obviously there are big improvements in if you go for a Galerkin method. Like of course Galerkin method, finite element is one, finite volume is one. We have the spectral method. So all these things, as I told you, are much more accurate than your finite difference methods, because the derivatives become exact. Yeah.
So more adaptability in the selecting either finite element or the finite volume. I think it's UCAMETOF is also going for the L-freak, where you have more adaptabilities there which can be used for the unified force. Okay, I think, sir, thank you. It's a wonderful answer from you. And now from the microphysics, I'm going to, because once you go for a very high resolution, from the convective parameterization, where the microphysics comes very important, and our microphysics, there is a lot of critical gaps is there in the microphysics, and there are a lot of, I think the previous session already mentioned about the critical investments in the observational advances from the laboratories experiments, new probes, and the next generation instruments in the space is, we record that. And the great emphasis on the laboratory work is apparently declined for the last several decades. And it's a question to Dr. Hugh Lewis, which is the essential ingredient for improving the process level understanding. Is it laboratories, experiments, or the cloud probes, or it's a space-borne instruments? Yeah.
Good afternoon all, and first just to say thank you for the invitation to contribute to this day, and fantastic to be back with so many friends and colleagues from NCMRWF and the wider Ministry of Earth Sciences organisations. I might also take Dr. Krishnan's lead by offering not to directly answer the question, so forgive me for that. But I hopefully will offer some comments on the wider use of observations, in particular for process understanding and their importance. And so it was great to hear this morning from Dr. Ravichandran about the importance of understanding as one of the core pillars for model development and application within IMD and within MOES. And just to echo that fundamental basis, almost however our operational systems are and climate simulations are developed, having that core grounding and understanding is imperative. And we'd also heard a rich history earlier this morning of the observation networks and observatories across India that form the basis for all that we're able to do today. So not losing sight of that in all of the sort of technology and the technical discussions we have, I think, is really imperative. So I really wanted to pause and acknowledge the fantastic resource that's really the envy of groups around the world that's now sitting here in India, specifically through the atmospheric research testbed that's being established and will be enhanced through the mission Mausam, and due acknowledgement to IITM for leading on a number of these aspects. So as I understand it, we're looking at a high altitude cloud laboratory which has been operational for some time, and really providing unique observations that help to develop the microphysics parameterizations. A fantastic and growing resource in central India of the sort of core of the test bed, with a whole variety of unique observations that and having those co-located in one place is really valuable to us. And then as part of the work of my group looks at developing with yourself urban scale simulation systems, and having something like the Mumbai X-band radar network, both for process understanding but also for model evaluation, is really, as I say, world class as a facility. So I really wanted to highlight that just this afternoon to echo how much we are looking to make use of those, both for model evaluation but also process understanding. I think with a number of academic partners in the audience today, and looking ahead to other meetings through the week as well, I would encourage both use of the data to motivate academic projects and comparisons. So we shouldn't, as operational centres, feel we need to do all of that research ourselves, but we share in those projects and so on. So I'm looking forward later this week, tomorrow and beyond, to look at some of those. And similarly for the UK, we are looking to invest UK academic project work into taking advantage of the atmospheric research testbed and applying to some of these process understanding and model evaluation questions. Maybe just one final thing to round off on, touched on a little bit this morning, but in order to really derive value from these unique observation sets, there's an imperative to make the data accessible. And I think, again, there are some opportunities here through things like the cloud servers and other methods to get these process level observations into the hands of research scientists, and the leverage that will come from the Indian academic community, but worldwide, people will come and address your problems. So I really commend you on development of the testbed, and I'm very excited by it. And I think that in terms of priorities, you're doing absolutely, you are much far beyond what we are able to do in the UK, and I would commend you for it, and really encourage you to keep going on that path.
Yeah, thank you. I think the question is related to microphysics, because I think already our secretary and Christian sir know about the under mission Mausam. We are planning a cloud chamber in the Pune. I think Christian sir already under mission Mausam we are planning also. So my question, it may be a question to you or anybody, like the last session mentioned about the OSSE, about the space. Anything like some type of similar OSSE type, but it's based on a process base, so that India is a vast country which are the locations where we need a distrometer or a probe or whatever, like any instrument. But it's like based on in the model where a different size distribution or a different type of a process where we record. So like OSCs, do you have some idea so we can having some modeling experiments or something? Anybody, anybody in the panel, some general.
I've grabbed the microphone and then I will give it up very shortly. But your question reminds me also about the value of satellite data beyond the assimilation work that was discussed in the previous panel. So specifically, as we're thinking about model developments to kilometer scale globally, and some of the questions that's addressing, having targeted satellite missions, I'm thinking specifically of the EarthCare mission, which is going to give us some unique insights on global convection and some of the deficiencies of vertical profile and vertical wind information in our models. Then we'll be able to utilize those. So I wouldn't want, just a reminder to all of us that these satellite missions have got real value for process understanding, for model evaluation, as well as then how they can get used in data assimilation. Do you want to talk to that?
See, right now we have one in Silkeda near Bhopal. Dr. Panditore is there. It's very close to Bhopal, central India, where all these depressions and low pressure systems from the Bay of Bengal pass through. And also there is one in the Western Ghats. So these are already very important areas, and that have been thought over keeping in mind the monsoonal phenomena. And now I think some studies are telling, even some of our own studies, that the depressions and low pressure systems are going to intensify as the climate warms. So already it's a very, very strategic area, and already many instruments are already deployed there. So having the RC centered around this is a good it's a good strategy to think about, keeping the monsoon as a core. I mean, that's very important for us, and what is going to happen to these monsoon precipitation extremes. Likewise, what is the priority? We have to fix that. Depending on that, you decide how you are going to do that. So,
Yeah, thank you. I think even our secretary also mentioned about the importance of OSSE, especially for the thunderstorm test beds also. I think I'm just adding for the. Yeah, so my next question is to the Professor UC Mohanty sir, having a lot of experience in the high resolution model. So my question is just a general question, like, sir, are our NWP operational models are designed to adapt the current global warming scenario, like the emission inventories or other ancillaries like land surface and all? Since the predictions of extreme weather forecast is a very challenge to the NWP and especially IMD and all. So is there any way of forward in tackling this type of issues? That's a question.
Thank you. So at the outset, I got the chance to congratulate NCMWF and IMD on 150 years of IMD and 30 years of NWP. So it is a good question, because as you told that actually in the tropics weather is more stable than mid latitude, but with that we get many extreme weather events like heavy rainfalls, severe thunderstorms, and tropical cyclone, and lightning, and so on. And nowadays heat waves. So all these things actually, except drought, most of the hydrometeorological extremes are localized and short-living. They are not for very long time. Heavy rainfall maybe 1 day or 2 days, not for 10 days type of things. So these type of things actually more depend upon initial value. And initial value means it should be consistent and reliable. If we have more observations, it is good, but then the gradient will be very large if a small error is there. So which will maybe blow up the model, or it will show that something is wrong there as a noise. So therefore actually, to put better initial conditions, as we discussed that we are enhancing the observations, it is very good, but and also getting the output and getting a bias correction, because any model, it has a systematic bias, and besides systematic, random bias is there. So therefore I feel that how to tackle these two ends, beginning and end, that having a better data, and suppose you want to put aerosol means you need chemistry. Aerosol cannot go alone, because in atmosphere we have temperature and moisture. So therefore chemistry will work. So put the chemistry and put all these things, whether that will really improve the extreme weather events. But for that, then you would need again a simulation of aerosol and all things, which you need inventory for that, which should monitor. So this is really a big issue to get that type of observations and making assimilation. And what we are doing assimilation also, as we go finer and finer, we have to see that it's a consistency quality. Most probably I feel AIML may be a better tool is coming, which can help both pre-processing and post-processing of the high resolution model outputs, so that it may be more consistent to give dynamic base, so that AIML should not be used as a statistical tool, but it should be as a physics-based hybrid AI/ML. So that may help to solve this type of problem. That is what I feel.
Since you are mentioning about a emulator or a hybrid type of modeling, it's generally questioning that whether the AML is going to nullify or because we know that in the model physics, a lot of uncertainty will be there. So if you are adding a emulator in replacement of a particular perturbation or in the model, in the physics perturbation, I'm saying. So are you artificially nullifying, or is it consistent with the model setup? So you mentioned about the AML. That's why I'm.
Yeah. You have to see that it should be consistent. So it should not be because otherwise again it will be, as I told, as you go higher and higher model, a little perturbation can grow much faster. And with climate change, the thing is happening that the variability became increasing. Climate change itself is not very much large because 1 degree in 100 years or 150 years. But actually the variability has increased. And in that, the extremes have increased. Like many places where we don't have heat wave, now we have heat waves. We have a lot of thunderstorm activities in monsoon time with lightning, because more casualties there during monsoon time, because that time a lot of water is there. And if it pre-monsoon or post-monsoon, then people know that there's a cloud is developing and a thunderstorm is there. But more casualties now in lightning during monsoon time, because that time you have a low-level clouds, and above that you have convective tall clouds and lightning, so which people are not knowing. So these things actually the variability which is increasing, and now similar drought is a long process. But now we have the flash drought, which is 10 to 15 days, which is break monsoon we are telling all the time. But now it is known as for agriculture purpose a flash drought, which have a lot of impact on the agriculture productivity. So all these things shows that there is more and more challenge as we solve the problem, and obviously climate change aggravating those things. So we have to see how to tackle it.
Because under climate change, I think Christians are already mentioned about the AR6 also. In the climate change, especially if you're looking at the NWP scale, you have to having some type of plans or something, where which part of the module in the model which can be need a more priority or some type of a more focus, as we generally looks at the model bias or model projections. And so some type of plan it will be good from the IPCC also. So that is you have something to add in the where the Professor Mohanty has mentioned about.
I think the moist convective processes, because it's all related. See, when you say moist convection, it's also related to turbulence. It is related to boundary layer changes. It is related to winds and how the convection builds up.
The feedback
so
process.
I think they are all interconnected.
Yeah.
You better to go with the phenomena. See all the processes how they are coming out, rather than going with that is the best way. Like tropical cyclones, are we getting what? So similar thing we have to do for the monsoon low pressure systems.
Okay. So since you mentioned about the tropical cyclone, my next question is to Professor Bhaskar Rao sir, because you have a lot of research and sir, tropical cyclone scale in the NWP model has been improved in the last decades, as you know that. And is it our approach, are we reaching a predictability limit in the tropical cyclone prediction? I think Mahabhadra sir will not accept that. Still, I am putting that as a discussion. So are we in the tropics, are we approaching some type of predictability limit? If it's not, do you have some way forward in improving the tropical cyclone predictions?
Thank you very much, Dr. Jay Kumar. Firstly, I thank the DG IMD, Dr. Mohapatra, Dr. Prasad, head NCMRWF, for asking me to come here for this function. I am very much thankful to both of them for inviting me. At this time, I should say, not pertinent to this question, but the Department of Meteorology and Oceanography at Andhra University had completed 50 years this year, and there was some meeting at that particular time. And I should gratefully acknowledge the benefit, academic benefit that had been incurred by the students, researchers, and faculty due to the close interaction between the Department of Meteorology and Oceanography, Andhra University, and the IMD and NCMRWF. I'm very much thankful to that. And the NWP at the Department of Meteorology was initiated as far back as 1978. The academic instructions have been started. Since then, research also has been taken up. For some reason, we have taken up the tropical cyclone research to start with because of some reasons. Since then, the Department of Meteorology has contributed significantly in the simulation of tropical cyclones, prediction of the tropical cyclones. And over the years, we have been following that. I do agree that we have made tremendous strides in the prediction of the tropical cyclones for the Northern Indian Ocean, because here. I also joined Dr. Mohapatra not to say that there is a limit of the predictability of the tropical cyclones. Normally in the mathematics we say that we always tend to, but we never reach that. So always there is a scope for improvement in the prediction of the tropical cyclones, so also say. But since the discussion has been going on, and now we have reached a stage that the models are being run at a very, very high resolution, less than 3 kilometers most of the times, especially when tropical cyclones are being predicted. And previously it used to be much coarser resolution, and so, and for the tropical cyclones, convection is very, very important. That has to be resolved, understood what is the interaction between the convective scale circulations and the large scale circulation in order to make a good simulation of the evolution of the tropical cyclone. At that time, convection parameterization used to be very important for inclusion as a parameterization, but now that the resolutions have come much, much finer, up to 1 kilometer, 2 kilometers, many people are saying K-scale modeling is going to be done. But at the same time, the prediction of the tropical cyclones need specific attention because for many reasons. These form over the ocean. The genesis is over the ocean, and also the evolution is over the ocean, and only when they come very near the land, they become very easy for us. So what is happening over the ocean, it is very difficult for us to make explicit observations of that particular system. So much of that has to happen from a kind of modeling of the phenomena. And coming to the point of the tropical cyclone prediction, if you are going to use a very high resolution model with a resolution less than 3 kilometers horizontal, there are many problems. First and foremost is how to get the clouds simulated in the model. And every one of us know we have many parameterization schemes. Many of them are available. If you take WRF model, which is very, very popular with the community. And many of the academicians, scientists, researchers, everybody use them as they are. As they're available with the WRF modeling system, everybody can download, put it on a computer and then try to run and then make. Several sensitivity experiments have been made because as a researcher who wants to explore how a system works, they have to do many experiments. Similarly, many researchers have been doing. But I think, in my opinion, if you come to the cloud microphysics, because you have said that, which is going to be very important for the tropical cyclone prediction, you see, which particular kind of, how do you resolve these cloud hydrometeors inside the cloud? You see, how many hydrometeors you would like to have? Some schemes use single moment schemes with the 3 WSM3 6 hydrometeors, things like that. But as you increase the, and at least we know that the global models, regional models use only WSM3 at this particular moment, because the other schemes we are going to use at that particular high resolution, you have to run the model at a very short time step, and you need a lot of computational time to do that. So this particular thing has to be, some optimization has to be done. And if you are going to use these cloud microphysics, every researcher who runs this model thinks that he is right. His experiment is right. Whatever the result he has got out of this model is right to him. You see, that's how the mind goes. But how to evaluate, how to believe whatever the model gives you, is there a possibility for us to get the observations of hydrometeors in a cloud system? What is the vertical structure of the hydrometeors inside the cloud? And many of these parameterization schemes like cloud microphysics is based on many approximations. When does the water vapor becomes liquid water inside the cloud? Is it just when the temperature goes below 0 degrees, immediately the water vapor gets converted into liquid water? When does the liquid water gets converted into rainwater? What is the percentage of that? Is there is some particular approximation. Somebody has made some observations, somewhere has put into that, and you try to do that. And I think in the Indian scenario, that particular kind of sensitivity experiments with the cloud microphysics has not been done.
Yeah, I think, sir, it's
it has not happened.
Oh, yeah, I'm just adding your same. It's a very valuable in the sense that you mentioned about especially the recurvature system, where that's a more challenging system, where we also did some of the where the most of the secondary process in addition to in the mixed phase, where you exactly mentioned in sensitivity to the recurvature systems improved. So I think we are completely agree with you. We need a more type of research, specifically the hydrometer distribution. If you are going for a double moment size distribution and mixing ratio of grapple or the other hydrometer species is very good. Sir, thank you. Sir, you want to add anything more in?
Yeah, a little more, if you permit, if you have time. Yeah, one important thing is how we go with the use of the parameterization of the cloud microphysics in the tropical cyclone models, like the WRF model, whatever it is. I would like to put forth to the MOAs all this, because a lot is being said about the observations. A lot of mission MOSM has come up now. Is it possible for us to have some particular kind of a field experiment where inside the cloud could be some measurements could be made inside the cloud, and a possible understanding of the vertical structure of the hydrometeors inside a cloud over the Indian region could be possible. You see, first over the land or also over the ocean. So I don't know, it is for some loud thinking has to be done. I think some good discussion how to get this information about and how to validate any of these model things, because as I said, everybody believes their result is going to be good, and then they publish papers. Many people publish. I also did. Apart from this, because I have heard many times Dr. Mohapatraji mentioning, we are good with the track prediction of the tropical cyclones. Very good. Track prediction is being done, but the intensity prediction is still going to be an issue all over the world, not only within Northern Ocean, but also the other ocean basins. So in that particular context also, the treatment of the cloud microphysics, because they are going to be so sensitive, some of the approximations that have been incorporated into these schemes are so sensitive. If you just change how much by a small fraction of the conversion factor, then it's going to make a lot of influence on the intensification, because some sensitivity experiments have been done, whether Graupel is going to be there, because that's a solid ice inside the cloud, ice, snow, and graupel or hail, whatever there is forming inside a cloud. So that particular conversion, those things, if they can be understood properly, I think the tropical cyclone prediction would go a little bit beyond what we have today. And one thing, last thing I would like to add, artificial intelligence, machine language models are coming up, where I think it may become possible for some of the parameterization schemes could be replaced with AI ML models. If that would come up, I think it will take us a long way, because you need not spend more computational resources for the prediction of the tropical cyclones. So if you mix the dynamical models as well as the AI models together, I think that's the way we go forward. I think that's where the future is going to be. Thank you very much.
Yeah, one quick question, I think.
My name is C.V. Srinivas. I would like to add one point to Professor Bhaskar Rao sir just mentioned about how to improve our prediction regarding the tropical convective systems. One instrument which can give more information about the clouds is the Doppler weather radars. And in the context of dual polarized radars now becoming available more and more, and this vertical structure of the clouds can be observed in our Indian region, and such kind of observations can be highly useful in validating our cloud microphysics schemes. Of course, we have done lots of numerical research on the tropical cyclone predictions with explicit simulations, where cloud microphysics plays a very important role. And a few schemes, like for example KM-British or Goddard schemes, a few schemes are found to be working very well. But as rightly pointed out by Professor, it is to be evaluated in our tropical Indian context. So for that, these observations which are already available with India Meteorological Department and many other departments like Department of Atomic Energy and Space, they can be used for this joint effort. We can have
joint one.
Yeah. Thanks.
Sir, you want to respond to, or I can go the next? You want to respond to that?
No, I agree with Dr. Srinivas, but I am not aware of any of the vertical structure of the hydrometeors inside a cloud system. If those observations are available with your group, then probably it would help the community. I'm not sure about that.
Actually, this gives about the size distributions of the hydrometeors, one aspect, and the dual polar our Pandit Rai also can comment, because they have a similar system located in the Central India and also on the West Coast.
I think I got an alarm from the food committee, so I need to. So the more detail will be in our So my next question to Dr. Saji Mohandas. I think that's my last question. There may not be any lot of questions from the audience because of the time constraint. So finally, as we all are going to the seamless modeling paradigms, and the divisions between the NWP and the climate models are currently narrowing down, and what is the future modeling roadmap and the strategies for the climate and weather modeling community? That's my last question.
Thank you, Dr. Jagamar. It's about a long-term vision. Because it is wiser to invest in a long-term vision than a short-term targets like that. So I believe that all the global NWP centers roadmap converges to a single concept, that is digital twin of the Earth system. So digital twin of the Earth system is not a simple forecasting system. It is a holistic environment Earth system, which is continuously being updated using real-time data to represent planet Earth, virtual Earth. So which can predict natural process as well as human impact also. So it will be a hybrid system which take full potential of the AML and exascale computing, etc. And it will be used to understand the improve understanding of the Earth process, as well as use it for the prediction of the climate adaptation. But it requires huge advances in observational. It's a very formidable target, because it requires huge advances in observational, computational, and modeling techniques. So in that respect, if you say that it's a huge target, and a lot of before achieving that, we need to have a lot of challenges to be addressed and lot of milestones to be achieved. So I will come to those milestones. First milestone is that, as Dr. Krishnan told, we should have a Earth system modeling framework which couples atmosphere, land, ocean, waves, cryosphere, hydrosphere, etc. And it should be able to simulate evolving active ocean circulations, this ocean circulations and cryosphere, and this all these components like the biosphere, land biosphere, cryosphere, hydrosphere, and balanced budget of energy and carbon. So also human behavior changes. So it's a for achieving that, another milestone we need to achieve is that kilometer scale global coupled model. So many people are talking about this kilometer scale global coupled model, and advantage is that kilometer scale coupled model can simulate the local and regional impact on the climate change. So it is having the largest uncertainties due to the model uncertainties as well as the changing climate. The natural variability also. So this kilometer scale, because coarse resolution model can resolve extratropical storms, but for tropical, so it will be improved performance in extratropics. But for tropical weather, it needs to be parameterized. So there it is having uncertainties and assumptions and inherent uncertainties, which will create a lot of errors. But this regional coupled model can fill the gap, but to some extent only, not completely, because there will be a scale break when you downscale the large scale forcing to the regional scale. Also, we cannot do upscale effects like from regional to global upscale effect without a two-way interaction. So the high resolution convection permitting kilometer scale global coupled model will promise very fewer unresolved processes and more impact on the regional climate. But we have to address those biases in the current bias in the model, like atmospheric chemistry, aerosol, cloud radiation impact, as well as land atmosphere exchanges. Another thing is that this kilometer model can predict all those variability. So what I meant said, this to achieve this kilometer scale, to come to the point, to achieve this kilometer scale, we should have another milestone. That is, it's a very because it will current scale, current computers, current models are not suitable for or say scalable for achieving that kilometer scale target. So what we need is the third milestone, that is next generation modeling system. So which can exploit the next generation SR scale computing system. So with this SR scale computing system, so we can it will produce enormous amount of data. So this enormous amount of data has to be processed, archived, processed, analyzed, visualized. So that needs public clouds and private public-private partnership, which can revolutionize, which can create a new paradigm shift in the large-scale data analytics and informatics. So this public, public cloud, which for data archival and analysis and visualization, along with the AML technique emulators, for which can give the shortest answer, the direct answer which we are seeking to the community. So if you like it or not, AML is going to play a role in analyzing the large, enormous data produced by the kilometer scale model. And you have to use it whether you like it or not. So, so the NCMRWF also is a part of the UM partnership, and the UM partnership is engaged in developing next generation computing modeling system based on LFIR model formulation with unstructured grid like a cube sphere. And so the final recipe is that you should have all the components like observational and modeling advances, plus kilometer scale global model, global models, global coupled models. Third is that cloud, public cloud for data sharing, and then then AML emulators, which can revolutionize the weather forecasting and climate adaptation.
Yeah, thank you. I think that is from my side. Any quick question? No, I think so many hands are there. I think
I have a mic.
Chairman is saying only one question. I think Raju can.
Complicated when it comes to the mountains such as Himalayas or Western Ghats. What are the ways one can at least attempt to improve this moist convective process? What is the good start? I just
No, I think the models are doing good. I don't know why you are saying it is bad.
Okay, so maybe I think
maybe we can discuss outside.
So I just quickly
So maybe one question. Questions are here also.
Yeah, one thing.
Sir, one quick comment, not question actually. So, how much cryosphere is important in our system modeling, and how much any model we have where the subgrid variability of glaciers are represented in our system models?
No, cryosphere is very, very important, especially for sea level rise. Much of the whatever sea level rise that has happened in the Indian Ocean, most of it is right now due to thermal expansion. But with the melting of these ice sheets, and it's going to be substantial.
And how much
globally it is, glaciers are contributing, glacier mass input is substantial. So when these extreme event, the cyclones and so the storms are just so elevated sea level, the impact is going to be very profound. So cryosphere has a big role there.
And our models are ready for this?
Yeah, they're doing, of course, there are strengths, there are weakness. So I cannot say my models are bad. Models are doing a reasonably good job. See the IPCC AR6 carefully. What is the observed increase in the global sea level rise? What is the contribution by the thermal expansion? What is the contribution by this one? They're doing a pretty good job. Now you have the altimeter from 1992-93. Just take a look at the IPCC CMIP6 models and take the look at the observations. Of course, regionally there are issues, and the cryosphere Antarctic ice sheet there are issues in that, but models are doing pretty good job.
Yeah, thank you. So that's the end of this session. Thank you very much.
Thank you. I want to congratulate NCMRWF and IMD for this important event. And I joined NCMRWF. I began my career here. Thank you.
I would like to thank the moderator, Dr. Jaykumar, and rapporteur, Dr. Anurose, as well as all the panelists for such an engaging panel discussion. I now call upon Dr. Ashish Rautre to present the panelists with a token of our appreciation. Dr. R. Krishnan, IITM. Dr. Hugh Lewis, Professor UC Mohanty, Professor A. Chandrasekhar, Dr. Saji Mohandas, Dr. A. Jayakumar. We have a very short tea break, after which we will assemble again for the next set of panel discussions. Thank you.